So we're going to begin here section 4.3, which is about the multiplication rule and conditional probabilities. So what does the multiplication rule say? It says, let's say you got two different events, A and B. Two events, A and B, within a probability experiment. So maybe like tossing a coin, rolling a die, drawing a card, something like that. The probability of A and B, remember this means A and B happening both, right? Both, A and B, both have to happen. This is given by the following formula. Probability of A and B is first the probability of A multiplied by the probability of B given that A has happened. So a little note here. When you see that, B vertical bar A, that's the one we underlined in blue. That means B given that A has happened, given that A has happened. So you're given some information. That is, A has already happened. Okay. So let's actually do some examples where we use the multiplication rule. A coin is tossed and a six-sided die is rolled. Determine the probability of getting the following. Number one, let's say you're interested in the probability of getting heads. Can't spell heads, can I? And the key word here is and, probability of getting heads, and 6. So we see this word here, this connective and right here. That's an indication, we might use the multiplication rule, right? Because the multiplication rule is used for and situations. Two events that are connected by an and. So we want to find the probability of getting a heads and also a 6. Okay, so I'm going to write this down. Probability of getting heads and a 6 that's equal to first the probability of heads. Right, that's using my formula, that's the green there. Times the probability of getting a 6, given that I've already gotten heads. So that 6/heads means 6 given I've already gotten a heads. Okay. So if I toss a coin, what's the probability of getting heads? Probability of getting heads. There's only one way to get a heads. That's getting one head. And there are two outcomes, right? Heads or tails. So 1/2. 1/2 is my probability of getting a heads. Okay, now I'm going to multiply this by the probability of getting a 6, given that I've already had a heads. So what's the probability of getting a 6 on my die after I got a heads, after I already got a heads? Well, getting a heads does not affect what I get on the die, right? My coin toss does not affect the die at all. So we can pretty much disregard the fact that we got heads on the first, on the coin toss. So we're just focusing on the die. What's the probability of getting 6 on the die? 1 and 6, right? There's 1, 6 on the die, and there's 6 outcomes. 1, 2, 3, 4, 5, 6. So 1/2 times 1/6. How do you multiply fractions? This is something you have to remember. Take the top times the top, which is 1, and you're going to take the bottom times the bottom. 2 times 6 is 12. So 1/12 is the probability of getting heads and 6 when you roll a coin, or when you toss a coin and roll a die. Let's convert that to a decimal. It's going to be about 0.083, roughly. I'm going to 3 decimal places. All right. Number 2, just to do another problem. So I'm tossing a coin, I'm rolling a die. What's the probability of getting heads and an odd number? Odd digit, we'll call it. So odds would be like 1, 3, 5, right? 1, 3, and 5 are the odds. All right, let's write this down. We want the probability of first heads on the coin and an odd digit. That would be on the die. Well, using the multiplication rule with an and situation, we want the probability of first heads times the probability of getting an odd digit, given we've already gotten heads on the coin. All right, so what's the probability of getting heads on the coin? Once again, it's a 1 in 2 chance, right? 1 head out of 2 outcomes, heads or tails, times what's the probability of getting an odd digit, given that you got heads on the coins? Well, getting heads on the coin doesn't affect what you get on the die, so you can pretty much disregard the fact that you got heads on the coin here. So getting an odd digit, you got 1, 3, and 5, right? 1, 3, and 5. That's 3 possibilities, 3 ways to get an odd digit out of a total of 6 outcomes, right? 1, 2, 3, 4, 5, 6. 3 over 6 is that probability. Okay, let's multiply these together. Multiply the tops together, you get 3. Multiply the bottoms together, you get 12. 3 out of 12. That's the same thing as 1/4. You don't have to reduce your fraction, but you do want to turn it to a decimal, right? 3 divided by 12 is 0.25. Exactly. So let's just write equals there. You don't need those approximately symbols or anything like that. All right, so let's go on to maybe cards. Cards are pretty common. Let's do some exercises here. A card is randomly drawn from a deck of 52 playing cards. And replaced. A second card is then drawn. So what's that saying? I'm going to randomly pick out a card from a deck, and then I'm going to put that card back in the deck, then I'm going to draw a second card. Determine the probability of getting the following. This is called with replacement. We're replacing that first card we draw. Determine the probability of getting the following. I won't put it that way. Determine the probability of getting. Let me say it that way. And we're drawing 2 cards, right? Taking out a card, putting it back, taking out another card. All right. How about an ace? And a face card. An ace and a face card. So we want the probability of an ace and a face card. 2 draws with replacement, right? We're replacing. Well, according to the formula, it's the probability of first getting an ace multiplied by the probability of getting a face card after we already got the ace, given that we got an ace. All right, so what's the probability of getting an ace? Well, remember there are 4 aces out of a total of 52 cards, so that's 4 out of 52. All right, now we're looking at the probability in blue there, probability of getting a face card after we got an ace. Now remember that you're assuming here you got an ace on the first draw if you're looking at this probability, right? Probability of getting a face card after you already got an ace. But that ace is going to get replaced, right? By replaced, I mean we're putting that ace back in the deck. As soon as we draw out the first card, which in this case we're assuming is an ace in blue, we're going to put it back in the deck. So our deck still has a total of 52 cards. So what is the probability of getting a face card? So how many face cards are there? A total of what? There are 3 types, right? Jack, queen, and king, but 4 suits. So that's a total of 12 face cards. 12 face cards, and we still have a total of 52 cards in the deck, right? That ace that we assumed we got on the first draw, we put that back in the deck. So there's still a total of 52 cards. So your bottom there doesn't change. It's still 52 on bottom. All right, so what we're going to do, we're going to multiply this together. 4 times 12 is 48, of course. And 52 times 52 is a big number. It's 2,704, 2704. And now we're just going to divide this out. Now this is going to get probably a small decimal. 48 divided by 2704. Okay, this is approximately 0.017. Doing 3 decimal places. If you want to go a little further, you can with these. Sometimes I'll probably go a little further when the decimals get really tiny. But try to go to at least 3 decimal places, at least 3. If you want to go 4 or 5, that's fine as well. All right, so it's a small chance, right? That's about a 1.7% chance. If you were to move the decimal 2 to the right, you could turn it into a percentage. You get 1.7%. So, number 2. Now, we're not going to write them as percentages. We're just going to leave them as decimals. That's pretty much the standard practice. Okay, so we're drawing 2 cards with replacement. What's the probability of getting 2 hearts? So that means a heart and a heart, right? A heart and a heart. So that's the probability of getting a probability of a heart and a heart. That's what it means to get 2 hearts. Well, it'd be the probability of getting first a heart times the probability of getting a heart on the second draw after you've already gotten a heart on the first draw. Okay, so we're going to do the green first. What's the probability of getting a heart? I pull a card from a deck. How many hearts do I have? 13, right? 13 hearts. There are 13 hearts, 13 clubs, 13 spades, 13 diamonds. I got 13 ways to get a heart out of a total of 52 cards. Didn't turn out too well. Okay, there we go. Now 52 is not drawing well. 5. There it goes. All right, then we got to figure out what's the probability of getting a heart after we already got a heart on the first draw. So we're assuming we got a heart on the first draw. That's this part right here. We're assuming we got a heart on the first draw. But remember, the card's going to get replaced. It's going to be put back in the deck. Put back in the deck. So we still have 52 cards in the deck. All 52 cards. So what's the probability of getting a heart, given we got a heart? So how many hearts are there? Still 13, right? still 13 because we put that first card back in the deck that was removed. And we still have 52 total cards because we put that first card back in the deck. Basically, we got 13 times 13 is 169. Divided by 52 times 52. We already said 52 times 52 was 2,704. If I approximate this in my calculator, it's going to be a little bigger than the last one. It's going to be 169 divided by 2,704. Oh, that's not an approximate. That's an exact situation. Let's say it's equal to 0.0625. I'm going to go to 4 decimal places here simply because it comes out exactly. It doesn't come out to a repeated decimal or a meandering decimal. So, yeah, roughly a 6% chance, right? Roughly a 6% chance. Okay, we'll do another one under this heading. What's the probability of getting first a black card? Well, just a black card and a red card. It doesn't say which one has to be first. You could have a red card and a black card, or a black card and a red card. Right, getting a black card and a red card, it doesn't matter which order you do it exactly. You can first get a black and then get a red, or you can first get a red and then do a black. But in any case, we'll just set it up. Say the probability of getting a black and a red. Be the probability first of getting black times the probability of getting red, given that we already got black. Okay, so what's the probability of getting black? Black on a draw. You got what, 26 black cards out of a total of 52. Okay, now we're going to multiply by what's the probability of getting red, given that we got a black on the first draw. Well, just because you got a black on the first draw, that's not going to affect anything on the second draw, right? Because that black card that we got here, assuming we got this black here on the first draw, that's going to get put back in the deck. So it's not going to affect the number of cards in the deck at all. Well, what's the probability of getting a red card then? Now that you have all 52 cards back in the deck, it's still going to be, what, 26 red cards out of total 52. So if you multiply this all out nice, on top, 26 times 26 is 676, right? And on bottom, if you multiply 52 times 52, that should be a 52 right there, right? Not 56. 52 times 52, 2704. Oops, wrong color. You divide that out, 676 divided by 2704. We get about exactly 0.25, right? 25% chance. 0.25. All right, I think we're going to quit this video, and we'll pick up in the next video with some more probability using the multiplication rule and